Why, hello there! Fancy seeing you here. Would you believe it? We are already at class 1.8, our second to last of Unit 1. Boo-hoo! Crying, tears, sadness, mourning. No, it's okay. We'll live. We'll be fine, I promise. There's no time for mourning, there's only time for math! Picking right back up where we left off. The name of the game today, we're going to continue getting practice with rearranging our equations. So aptly so, the title of our lesson today, Class 8, Unit 1, Let's Talk, Rearranging Equations, Part 2. Cool. So last time we chatted, we said that the power to rearrange equations, one of the many ways in which we apply our mathematical superpower of making things look the way we want them to look, well, it can help us find certain forms of equations that are more useful or more powerful for us than others. There's one last place we want to talk about today where rearranging is helpful. But first of all, remind me of the two we did last time. What two places did we see that the ability to rearrange equations, rewrite them in slightly different ways, turned out to be useful or powerful for us? Take 10 seconds, remind me, go ahead. And stop. Well, the first place that we saw that was kind of interesting to us, well, maybe I was working with some shapes. And those shapes, maybe I knew like their volumes or their areas or their perimeters. Well, if I rearranged an equation, I could represent a dimension of a shape, like its length or its width or its radius, in terms of other pieces of the shape that I already knew. Another place where we saw that this was a particularly powerful tool, well, maybe I've got a temperature in Fahrenheit, and I want to convert it to Celsius, or something in Celsius that I want to convert to Kelvin. So the ability to do some rearranging there could be something powerful. And then the last place that we'll talk about today, so when I get to Unit 4, so a couple months down the line, but still something to look forward to, because of course we're looking forward to it, well, if I'm thinking about linear equations, another thing that I might be interested in doing with them is finding a way to turn them into visuals. In other words, to graph linear equations. And when I'm graphing a linear equation, it turns out that equations of lines have a particular form that is especially powerful for graphing. That form, we'll see it again soon, although soon is of course never soon enough. That form looks something like this. We say y is equal to mx plus b. Maybe you've seen this form before, maybe you haven't. However, you don't even need to know what y, mx, or b are in this case. The only thing that we want to know is that this equation is really powerful specifically because the y is by itself. So our goal here, given a linear equation, I often want to isolate that y. So let's take a couple of linear equations. In this case, they're going to have two variables, x and y, and the goal is to get the y by itself. For some reason, we don't know yet. But hold on to it. All I want to know now is that the ability to put it in this form is really helpful. So let's take a look at these two together. I've got 7x plus y equals 8. Well, you tell me, my goal is to get the y by itself. What's in the way and what choice can I make to get rid of it? 5, 4, 3, 2, 1. Shout it out. To get this y by itself, all I need to do is... Ah, my ears. You are so loud. I need to subtract the 7x. So I have a 7x plus y. To undo my positive 7x, I'll use a negative 7x. On the left side, they undo each other. I'm left with y. And then by convention here, I write it mx plus b. So I usually write the x thing first. So I'll write the negative 7x before I write the 8. And of course, that 8 is a positive number, so it will be plus 8. Cool. So there's my answer. Same thing with this guy, 5x minus 2y equals 4. The only difference here is that now there's a number attached to the y. But same idea. If I want to get the y by itself, give me two choices I need to make here to get the y by itself. Go, 10 seconds. 5, 4, 3, 2, 1. Well, I need to get rid of the 5x. I need to get rid of the negative 2. If we follow our reverse order of operations, that 5x is going to be easier to eliminate first. So I'll subtract 5x from both sides. On the left side, they undo each other. I'm left with negative 2y equals negative 5x. And then again, I'll write plus 4. Usually I write the x thing first, so the negative 5x I'll write first. Then I have negative 2y equals negative 5x plus 4. I want to get the y by itself. Well, I should divide by negative 2. And for an equation, right, I need to divide the entire right side by negative 2, which means both the negative 5x and the 4 need to get divided by the negative 2. Let's think about it piece by piece. Negative 2 over negative 2, of course, these undo each other. So I've got my 1y here. And then negative 5x, if I divide that by negative 2, well, usually I like to have the x by itself in this form, and then it's attached to this thing m, whatever that m is. You don't need to know it yet. But I would take the negative 5 and divide it by the negative 2. That would be the thing attached to the x. Well, negative 5 divided by negative 2, that's 5 over 2. I could write it, of course, as negative 5 over negative 2, but what's the issue? 5 seconds, 5, 4, 3, 2, 1. Well, negative divided by a negative is a positive, so I should write it as 5 halves rather than negative 5 over negative 2. And then last thing I need to do, I divided the negative 5x by the negative 2. Let's also divide the 4 by the negative 2. 4 divided by negative 2 is, of course, 3 billion. So y equals 5 halves x minus 2 is our equation in this y equals mx plus b form. Cool. Let me give you 3 more to do. So again, your goal is to get y by itself. 6x plus 3y equals 9. Negative 2x plus 5y equals negative 15. 7 parentheses x minus 2y equals negative 21. Let's solve each of these equations for y. Go ahead. Give yourself a 3-minute timer. Play around, see what you get, and we'll chat. Okay, stop your playing. Playtime's over. 6x plus 3y equals 9. Well, I want to get y by itself. First thing I should do, reverse order of operations. Let's subtract our 6x from both sides. When I do that, I've got 3y. Again, by convention, I'll write my negative 6x before my plus 9. Last thing I need to do, well, I need to divide y by 3, which means everything needs to get divided by 3. So if I divide 3y by 3, I've just got y. Negative 6x divided by 3. Well, negative 6 divided by 3 is negative 2x. And then plus 9 divided by 3 is plus 3. Cool. Next up, negative 2x plus 5y equals negative 15. So I want to get y by itself. Reverse order of operations. Let's start by adding 2x to both sides. Negative 2x plus 2x is 0. So 5y. Usually, again, I write the x thing before I write the number thing, so 2x, then the minus 15. Last choice between me and y by itself, I need to divide everything by 5. So I'm going to divide each of my terms here by 5. When I do that, 5 divided by 5 leaves me with just my y. I have 2 divided by 5, so that's 2/5, and then I'll write my x off to the side, as I have before. And then negative 15 divided by 5. Well, that's negative 3. So y is 2/5 x minus 3. And finally, I've got 7 parentheses x minus 2y equals negative 21. Well, I could, of course, do what with the 7? If I see it next to parentheses, I might want to distribute. But if I multiply by 7, if I'm dividing by something to get y, I'm going to need to divide by the 7 anyway. Let's divide by the 7 now. So I'll divide both sides by 7. When I do that, 7 over 7, these undo each other. I'm left with x minus 2y on the left side. And on the right side, negative 21 divided by 7 is negative 3. Let's minus x from both sides to get closer to our negative 2y. I've got negative 2y equals negative x minus 3. Last move, let's divide everything by negative 2, divide by negative 2, divide by negative 2. Well, negative 2 divided by negative 2, I'm just left with the y on the left. And on the right, if it helps, remember negative x really means negative 1x, and negative 1 divided by that negative 2. Well, I could write it as negative 1 over negative 2, but I shouldn't leave a negative over a negative. That's going to become positive 1/2. Write my x off to the side, and then negative 3 divided by negative 2. Well, that's positive 3/2. Cool. So again, we'll see in a couple months why it is powerful to have lines in this form. But in this case, just knowing how to get there is the only thing that we want to concern ourselves with. Fantastic. If you're interested, feel free to look it up. Nothing wrong with doing a little math outside of math. Anyway, with all of this said, now that we know how to solve equations for a variable, there are a couple of types of equations we'll encounter that will leave us with some questions that we want to answer and some nits that we want to pick. So let's do some nitpicking. For example, take something like this, P equals F over A. This is actually a physics equation. Pressure is equal to force divided by area. So if I want to find the pressure applied on a surface, I take the force that I apply to it, I divide it by its area, then that will give me the amount of pressure. But anyway, I'm asking you to solve for A here. What's the problem with that? What's different about where this A lives in the equation based on the types of equations that we've seen before and I've asked you to solve for a variable? Tell me what's weird, what's wonky, what's different. Very nice, invisible person. Well, in this case, the A lives in a fraction. And specifically, it's in the bottom of the fraction. It's in the denominator. So I want to get this A by itself. The problem right now is that the variable that I'm trying to solve for is in the denominator of a fraction. Well, then put your strategic mathematical thinking cap on. You want to get the variable probably to a place where it's no longer in the denominator. What choice could you make to move this A from a place where it's doing division to a place where it's no longer doing division? Take 20 seconds, take a risk, take a chance. Who cares? Come up with a strategy. What could you do to get rid of this A in the denominator? Alrighty, well, if you're like me, you might think back to some previous classes. If I have a denominator that I want to get rid of, in this case, division that I want to undo, well, a potential strategy for me might be to take this division by A and undo it using multiplication. So in this case, my strategy, when I see a variable in the denominator that I want to solve for, I can always multiply both sides of the equation by the denominator, because that will get my variable out of a place where it's doing division and into a place where it's doing multiplication. So let me multiply both sides of this equation by A. On the right side, times A divided by A, well, that just leaves me with F. And then A times P, well, that's just A times P, which I can write as AP. And then I want to get A by itself. Well, now I'm in familiar territory. All I need to do, let's divide both sides by P. On the left side, the P's go away. I'm left with A equals F divided by P. Cool. Same idea. Let's try it again with two more. So again, I know my strategy. If I'm trying to get a variable out of the denominator, if I multiply both sides by the denominator, then I should be good. Here are two slight variations of this. Let's take a look at these together. 3 equals h over j minus k. So I see a j in the denominator, but I also see a negative k. Give me an option here. What choice could you make? Alrighty, maybe you thought about it. Maybe you didn't. I dropped my pencil. 3 equals h over j minus k. Well, in this case, I could start by multiplying by the j. That's my strategy. It hasn't gone wrong so far. But I could also start, and there's no right answer here. I see this minus k. I want to get closer to a place where the j is by itself. Let me start by adding k to both sides. So when I do that, I add k, subtract k. Those undo each other. I get 3 plus k equals h over j. Again, I'm just using my order of operations in reverse. In this case, undo my subtraction before I undo my division. Now, I'm in familiar territory. I want to get j out of the denominator. Oops. Let's multiply both sides by j. Times j divided by j. These undo each other. Well, now I've got j times 3 plus k equals h. And once again, I could distribute here, or alternatively, I'm trying to get j by itself. Well, what's attached to the j right now? The 3 plus k. So I'll undo it using my division. On the left side, my 3 plus k's, they undo each other, and I'm left with j equals h over 3 plus k. And then the same idea here, p minus 1 over q plus 1. Again, pause, take a second. What's the difference here about where this q lives in the denominator? Talk to yourself. Talk to your family members. I don't know. Talk to the wall. Talk to the voices in your head. What's different? 5, 4, 3, 2, 1. Well, I've got a q plus 1 instead of just a q, and I'm trying to get the q by itself. But my strategy, if it ain't broke, don't fix it. It hasn't led me wrong so far. Let's try multiplying both sides by the denominator anyway. Let's say that I multiply by q plus 1. I want to turn the denominator into something with multiplication. Well, if I multiply by q plus 1, divide by q plus 1, those undo each other. I'm left with p minus 1. And then on the right side, I've got r times that q plus 1. Okay, well now I want to get q by itself. Again, same idea, I could distribute, but to make my life easier, if I multiply by the r, I'd need to divide by the r anyway. Let's start by doing the division. So I'll divide both sides by r. I've got p minus 1 over r equals q plus 1. Then last thing between me and the q by itself, well, I need to subtract 1 from both sides. When I do that on the right side, they cancel out, and I'm left with p minus 1 over r minus that 1 equals q. So again, if it ain't broke, don't fix it. My strategy has brought me thus far. I can hopefully have faith that it will not lead me astray. Cool. Let's do 2 more. So same idea as above. I want to solve for v in the first one, solve for e in the second one. I could read them to you, but I trust that you're literate. Your English teachers have taught you well. Let's find the value for v. In this case, where v is by itself. Again, find the value for e. In this case, where e is by itself in each of these equations. Go ahead, play around, and we'll chat. Are you done? No, you're not done? Okay, sorry, I'll give you a little more time. How about now? Are you done, Yao? Are you done? 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 Okay. No, you're still not done. Okay, I'll give you more time. I'm kidding. W minus 7t over v equals g. So I want to get v by itself. Again, same idea as before. Well, I'll use my reverse order of operations. I'll subtract w to begin with, minus w from both sides. I've got negative 7t over v equals g minus w. And then again, same problem. V's in the denominator. I want it in the numerator. Let me now multiply both sides by that v to get rid of my division. So on the left side, times v divided by v, these go away. I've got the negative 7t left over. And then I've got v times g minus w. I'm trying to get the v by itself. It's currently joined to something in parentheses. Well, let's undo that parentheses. In this case, it's multiplication using division. So I'll divide both sides by g minus w. And I've got negative 7t over g minus w equals v. Cool. And then finally, ab equals c over d minus e. Same idea as before. I'm trying to get this e out of the denominator. Let's multiply both sides by that denominator to accomplish our goal. So on the right, I've got ab being multiplied by that d minus e. And on the right side, well, I've got d minus e divided by d minus e. That just leaves me with the c. Now I want to get e by itself. Well, let's get rid of that ab first. Again, I could think about getting rid of that d here, but in this case, I've got some parentheses in the way. So I've got d minus e equals c over ab. Last thing standing between me and my variable by itself. Well, I need to subtract d from both sides. In this case, I'm left with negative e equals c over ab minus d. And then the last thing that I need to do, well, I've got a negative e. So if I want to write positive e, I could think about multiplying everything by -1. Negative e times -1 is e. I've got negative c over ab, and then positive d. Very nice. So let's do a couple more together, and then you're free. So here, v equals 2 pi r h plus 2 pi r squared. Negative 9x plus 6y equals negative 15. M over n equals p over q plus r. So same idea. You've got a variable that I've asked you to isolate. In this case, maybe you've got it in the denominator, maybe you don't. Maybe you're just trying to get it by itself. Either way, you know the drill. Use your reverse order of operations, use your inverse operations. Let's do it! And stop. So v equals 2 pi rh plus 2 pi r squared. In this case, this is a formula for volume. I honestly am so sorry. I don't remember what formula for volume it is. I promise I'm a good math teacher. So v equals 2 pi rh plus 2 pi r squared. I want to get h by itself. So I'm trying to get this h here alone. Well, let's get rid of that 2 pi r squared first. Minus 2 pi r squared from both sides. On the right side, they undo each other. I've got v minus 2 pi r squared equals 2 pi r h. Then the last thing I need to do, well, I want to get the h by itself. The thing attached to it is the 2 pi r. Let's divide both sides by 2 pi r. So we get, on the right side, just our h. And on the left side, v minus 2 pi r squared over 2 pi r. Cool. Negative 9x plus 6y equals negative 15. So reverse order of operations. Let me undo my negative 9x first by adding 9x to both sides. When I do that, negative 9x plus 9x is 0. 6y equals 9x minus 15. Again, by convention, our mx plus b thing, usually the x goes first. And then I just need to divide both sides by 6. So I'm going to divide everything here by 6. Well, 6 divided by 6 just leaves me with my y. 9x over 6, well, I can do 9 divided by 6. That's 3 halves if I simplify my fraction. And then 15 over 6, well, if I simplify my fraction, that is 5 halves. So y equals 3 halves x minus 5 halves. And finally, m over n equals p over q plus r. A couple different ways to do this. By the way, notice, what kind of equation is this? I've got a ratio equals a ratio. That's a prime example of a, shout it out. It's a prime example of a, not that loud, my ears. It's a prime example of a proportion. And proportions can be cross multiplied. So on one side, I've got my n times my p. And on the other side, I've got my m times my q plus r. Cool. So I'm trying to get q by itself. Let's divide both sides by m. Again, you're welcome to distribute, but you need to divide by the m anyway. You might as well do it now. np over m equals q plus r. Last thing I need to do to get the q by itself, let's subtract r from both sides, plus r minus r. This becomes np over m minus r equals q. Beautiful! Congratulations. You've done it.